this is to some idea about the normal distribution. I'm not interested in taking you to the first years of PDS, but review about the confidence interval concept. Some example, let me discuss it and then move forward. As you see here, this is a normal distribution. This is the one which is 95% confidence. The normal distribution of the area is 100%. 95% of the area is covered by the two limits, the lower limit and upper. So what does it mean? How do we link that idea into our so what does it mean? It provides a range of values within which the statistical constant parameter lies most of the time. What is a parameter? What is a parameter? Parameter is only one value which we are trying to find. So obviously that when you say parameter, it comes from the population, large number of thousands and so on. Say for example, our interest was in 1998 prevalence of STDs and that's it. So the plan was to have Kerala and Tamil Nadu join together. Very difficult to get Kerala government clearance to the so drawing like this is a problem there. So therefore we have gone to Tamil Nadu. It means that it was taking the whole India. Let's say what is the prevalence of Tamil Nadu? Ideally speaking, this is the disease which affects the adults. Therefore, we have to study each and every adult in Tamil Nadu to find out what is the disease. It's not possible. We get a sample and we get an estimate and we say and do what? We say this. Okay, that is what we did. This is what the prevalence of uh, STD, HIV in Tamil Nadu. How do you calculate it? I'll come back to this. So it provides a value, a range of values within which statistical parameter. Parameter is a single value which we are trying to get, but at least we will not get if you don't know what it is. These are all the constraints. So I'll come back to this later on. This may not be necessary for you. This is the prevalence. So 1.8% is the adults. So for 18 to 45 years old, the prevalence of HIV was 1.8%. Can I say this is the population parameter? If you take 100 individuals from Tamil Nadu who are adults, then the prevalence is 2%. Yes? Or it could be as low as 1% or as high as 2.5%. What is saying in 95% confidence? That what? The population parameter, I do not know what it is, but it is most likely to fall between 1 and 2.5, 95%. So it means when you say 95% confidence interval, we are talking about the population value. So nobody knows what it is. What we are saying, if you take large number of samples and study them, what we are saying that value, what we are getting must be closer to the population parameter. The difference between the population parameter and the sample value must be smaller. But we don't. How can they challenge you? People can challenge you. No, it cannot be like this. 1.8%. That time, that ICMR opinion was that there is no HIV in India. It is there in certain pockets place, high risk. They say pockets is a high risk place, like truckers and helpers, commercial sex workers. These kind of high risk groups, they have actually not in the general population. So we analyze the data by rural and urban for the same results. What does it imply to you? Similar results around 1.8%, 1.5% in rural and urban area. Similar. What does it mean? It means that already the epidemic has reached the rural area, which is generalized. You understand? So we are comfortable in doing this. So presenting this. Then we presented this data in ICMR New Delhi. This is what that somebody asked. Go into the community. What is the guarantee that you have not studied broken houses? There are women who are adults who are highly infected or infected. Therefore, you would have studied by mistake. You don't know who is who. So, therefore, we should not depend on this. This is in the ICMR campus. We disseminated this. What does it mean? They said we will do a rapid study in Tamil Nadu. We will send our team to Tamil Nadu to study, validate this. That means they will do a quick study and see whether they are going to get the result. Now, I am going to ask you that had they come and done the study here, and the prevalence is not 1.8%, 1.2%, they did not come. Supposing it is to 1.2%, what do you conclude? Our study is wrong, both are same, one at a time. Yes, sir. Qualified means what? No, is it same as 1.8% or how many? Please remember, this is a very important question. You get involved in this kind of work tomorrow. ICMR is going to come and they have done the study, and the result is 1.2%, but we presented as 1.8%. So, do you say the 1.2 is as good as 1.8%? One minute. So, she's saying you find out the confidence interval for that value also. How does it help? That means still you have not understood the confidence interval concept. Remember, what we are saying is that the limits, the two limits, what does it imply to you? We are saying population parameter is a value, which I don't know what it is. But I am saying 95% of the time it is most likely to be within these two limits. So it could be 1.2, it could be 1.1, it could be 2.2 or whatever. So as long as the value which falls between these two limits, it is the same. It is 1.8 or 1.2, they are all going to be same, and it is around the probably 1.8, the value 1. You understand? So how confidently you are saying that based on the normal distribution concept, 95% of the observations are going to fall between these two limits, because you put the limits there between the two limits, and confidently you are saying that it's not going to go away that 95% of the time. Only 5% of the time is most likely to fall away from this. You understand? So the 1.1 if they say, or 1.2 if they say, still this is as good as 1.8, and they are all meaning the same. So the variability which we talk about between the two limits, it's a sampling variability. You understand? That is the meaning of 95% confidence. and we don't use the p-value to qualify based on whether it covers 0 or 1 based on the null hypothesis. We just conclude whether it's a good confidence interval or bad confidence interval and so on. Okay? Any question? Please remember, now I'll go back to confidence interval formula. How do we calculate it? You have done a study that we estimated your proportion, percentage of people have the HIV. That is your point estimate, and this is the point estimate. So here at 1.8%, and how confident that we want it to be, 90% or 95%. Some of the biochemistry studies and pharmacological studies, they establish 90% confidence. I don't know, you mentioned that. 90% confidence. Sometimes this is a standard error which tells about the data. Now let us go back to your first year. What do we mean by standard error? Why not standard deviation? It tells you about the variability of the means. We are talking about the repeatability of the studies. If I do 100 studies, 95 studies mean value or the parameter or the proportion will fall between the two means. So therefore, when you talk about the repeatability of the studies, that we need to use standard error and not standard deviation. Though the standard error is calculated from the standard deviation. There is a difference in the form. You understand? The standard error, the moment you talk about that, so comparing in the t-test, comparing the two means, we use standard error because there are two means. To proportion, you calculate standard error because the two means, two groups. We understand this. So therefore, standard error is used. So you have to have a very simple formula. This is 1.96 standard. Mostly we use for convenience 2. 2 times the standard error. Okay. So 2 times the standard error plus your point estimate. In my study, it is 2%. About 2% plus 2 times the standard error. That gives you the lower limit and upper limit. Right? Any questions? The 1.2 the ICMR value and R value is 1.8. The variability which you see is because of the sampling. That is what it means. The variability between the two limits or around that parameter is because of the sampling. Okay. Any question? Now we use software, but many times we use this manually and calculate, compute your standard error. You will better understand this concept better. Now this is when you say that what do you mean by precision and all that is basically that you see here in the normal distribution. This is the population parameter within that. This is nearly 2 times standard error. This is called the precision of test, which we use in the sample size calculation. How precisely you wanted to have the distribution. So for example, if you have to do a study, ICMR wanted to plan a study, the prevalence is 2% as reported by Vellore, that you say, if you want to do a study, how precisely you wanted to study that 2%. You understand what is the precision? How precisely you wanted to estimate. It could be 3% or it could be 1%. Is that the precision? Or it could be 2.5%. 0.5 is the precision. Or 1 is the precision on it. You understand? So for example, the prevalence of gonorrhea in CMC lab is 5%. 5%. They wanted to do a good study. They wanted to estimate the sample size. How many blood samples that the subject have to be screened to estimate What is the prevalence of gonorrhea when they come to, say, for example, when you are a dermatologist, we have dermatology. How do you find out? 5% is the prevalence reported by something. Now, the next question is, when I do my calculation, how much variability that I could allow? I cannot say I will find exactly 5%. You cannot. You can plan 5%. At the end of the study, you will not get exactly 5%. So you need to allow some kind of variability. That is called the precision of this. So you would say, somebody will say, okay, let us plan to have 1% variability on either side. What does it mean? It could be 4% or it could be 6%. You understand? That is how you decide your precision of this. So let us have wider variation. What will happen in your sample size? If you have a wider variability, the sample size will go. If you have a narrow variability, sample size will go up. If you have plus or minus 1% versus plus or minus 2%, what will happen? The sample size will go up. High in the side, this will come down. These are all the very important ingredients to decide your sample size, especially in the estimation stage. So we start off with what is a precision, what is a confidence interval, how do we interpret it? The confidence interval many times Kant has suggested how to go about it. It's a very important concept. We don't use it in India. The reason is many people don't teach and many people don't know how to interpret confidence interval. They are uncomfortable. This slide. This one. Yeah. On either side, because the symmetry, whether you say two sides this side or two standard error that side, both are same. Yes. Yeah, because that is the unit 2%. I plan 2% precision on either side. He plans precision 1% on either side. It's called the still precision. So he will get a very high number as compared to she. You understand? So we need to do some exercises and see, because when you have a software, it gives you the flexibility to have a matrix of information by varying your precision. But you should know how to be better. We will show you that. How do you decide precision? Is a very, say for an example, the prevalence of spousal violence, which said the Congress leader for big study, which we studied 10,000 women in India to study the spousal abuse. So we did the analysis in both writing and data concept as well. The prevalence of spousal violence, any form of violence, it was 25%. Prevalence is 25%. Incidence is 10%. Since the marriage for 1 year, the prevalence of incidence is 10%. First question is, if I take 25%, will it give me a higher sample size, or 10% will give me a higher sample size? If I take incidence, will it give me a higher sample size, or 25% prevalence will give me a higher sample size? 10%. We'll discuss about it. Now let's say because the two different study designs, this is 10% versus 25% is the prevalence of spousal violence. How much precision that I should have? How much could it vary when I do a study? 5%. It's a consensus. Sometimes it take, I don't know what the plan is, 25%, 20% of your p value may be consensus value for, it may be a value for sometimes it will be very high. Let's see. It's basically a consensus statement. I remember when we planned the study, that STD study, um, there was a PG from the neurology department, Madras Medical College. He did a study in Kanjipuram about this. His boss, Dr. Kantaraj, head of neurostatistics, start with the 5% samples. How do you put your precision for 5%? More say that just say start out with this. Say something, no harm in saying something. 1%, that is what we wanted to have. Laboratory based, we decided to have 2%. You can decide your samples. We'll do this calculation. So it depends on the budget as well. So 1% or 2%. So if you take 2%, you need to have around 400 subjects and so on. So it's a very simple, easy formula to do that. We are not here to teach the formula to the software. So therefore, now we need to look at, this is what we are talking about today. Now at the moment, what the estimation problem in statistics. So the one Kant spoke about hypothesis testing. The whole morning about clinical trials, comparing two groups. These are all called hypothesis testing. What I am talking about is that is estimation problem. First problem is how much is the problem? That is estimation problem. How much is the estimate? How much is the gonorrhea? And so on. How much is the migraine? Let's say that what is it? Migraine in your headache, and so on and so forth. So these kind of things are called the estimation problems. Then we move on to testing hypothesis. Next thing is, this is computer literature. For example, when he presents this is the baseline data, intervention and standard. This is the baseline data and the follow-up data, the difference between the two time points, and he is comparing these two groups, and the difference is this. And this is the lower limit, and this is the upper limit. Minus sign, the smaller the value is, the higher value. Tell me that having listened to the confidence interval so far, the first line, is it a significant difference between, I should not ask, significant p value, but let us don't look at the p value, but tell me how do you interpret this sentence? Having discussed about the confidence interval, there are various confidence intervals here. Which one is the best? How many people are voting for second one? How many people are we discussed? I'm going to confuse you a little bit now. Morning we said the confidence interval should cover the population parameter 95% of the time. If the study gets repeated 100 times. Population parameter. Okay, that is a concept that now tell me. Let me repeat it again. If the study gets repeated 100 times, that whatever you get is going to get covered 95% of the time. So, or the population parameter gets covered 95% of the time. After two definitions, which is correct. There are two definitions actually you come across. The population parameter gets covered 95% of the time in the confidence interval, or the study gets repeated 100 times. Whatever estimate you get every time gets covered in the confidence interval 95% of the time. Which one is the correct definition? First. So the confidence note talks about the population parameter. Okay, that is everyday discussion like this, if you repeat the study 100 times, you get whatever you get, you will fall between the two limits. Forget about it, that's not correct. Now tell me that, so therefore, what message is repeated, repeated. So if I have a wider confidence interval, it is going to cover the population parameter easily. Yes? So therefore, you would vote for the wider confidence interval. Smaller, narrower one is a very related. Standard, please let us go back to the confidence standard error form. When do you say the data is very reliable? When the standard deviation is very small. Therefore, the standard error is small. Therefore, the confidence interval is expected to be very narrow. A good confidence interval has to be a very narrow confidence interval, which is very reliable. So you should not vote for wider confidence interval. Wider because the standard error is very large. Standard error is large because you study less number of subjects. These are all the basics that we should remember. Now, read this example. This is from Karnataka. That the ministry decided that it's very difficult to get psychiatrists to work in the community, rural areas. Therefore, being trained psychiatric community health workers to treat psychiatric maladies. It's a good idea if it works. Therefore, they have trained. This is the data. What is the question? Is it okay? This is the training concept. The community health workers get trained 35, and there are 35 psychiatrists. Then after 6 months of training and practice and so on, that data, the outcome was optimal cure, suboptimal cure. This is the data. What percent is a suboptimal optimal cure in psychiatrist? This is psychiatrist. 35 psychiatrists, optimal cure was 63%. Okay. Here, community health workers, 40%. So 23% difference. But it was not statistically significant because it is 0.09. So what is the research question here? What is the research question? The training in, no. God, she is saying that the community health workers are as good as a psychiatrist. If that is true, then we can train community health workers. Is that right? Okay. So this is so what is the conclusion? What do we conclude now? It is not significant. But it is not statistically significant.
Meaningful.
because it is not statistically significant. What is a null hypothesis here? Now, if if I were yesterday, I would raise a hypothesis. Null hypothesis is that community health workers are equal to that psychiatrist. What is the alternative hypothesis? Not equal. So if I don't reject the null hypothesis, what would I do? If I were yesterday, accept the null hypothesis. This is what happened. This was very happy. It was not significant. Therefore, accept the null hypothesis and train more community experts. You understand? This is what the Kant was saying that, I mean, there is a lot of discussion about the Fisher. This is the Fisher's statement. You should never and ever accept the null hypothesis. This is a philosophical statement. And I remember there was a very brilliant person from Rwanda. I presented this data. What would you do? What do you conclude? You need to make a decision. And I realized that they were not updated with the equivalence concept and not inferiority. So therefore, this is very important. Don't ever accept the null hypothesis. If there is a question, something related to that, you need to something called retrospective power calculation. Yesterday, I remember I told you about the Blackwelder concept. If it is the p-value is greater than 0.50, 50%, probably you would consider equivalence. You understand? Proving the null hypothesis. Retrospective. That is what we need to do this. Okay? This is about, so what we have discussed so far is, and the deviation talks about the variability among the observations. We expect a smaller standard deviation, less variability, therefore less standard error, therefore very tight confidence. That's it. And face the hypothesis very clearly. Don't ever accept the null hypothesis. If you wanted to accept the null hypothesis, then go back to the papers like I said. That was great.
Confidence limits. If it is narrow confidence limits, you have a good effect size. Is that how?
No.
How can you?
Effect size doesn't decide your confidence.
So what is the difference between effect size and confidence limits? How
Say
can
for
you
example, the effect size of odds ratio is 3, plus or minus the standard error. That decides your width of the confidence. What is your question? Can you please repeat the question?
the difference between effect size and confidence limits? How can you explain?
Effect sizes, we say effect sizes, for example, difference between two means is called the effect size. Difference between two proportions is called the effect size. Measures of the effect is odds ratio. So odds ratio is, say for example, 4. That is measures of the effect. So this is it is called a point estimate. Effect size is a point estimate. So confidence interval is how this is likely to vary if the study gets repeated. If I repeat my study, that same study in my place, what would be the value that I would get? It tells you your value would be somewhere between the students. That's a repeatability concept. So they are two different entities. Effect size and